posted some information on some quantum physics, some gravitational physics, which doesn't seem like it corresponds to one another too well. But I wanted to talk about it. Methuselah's star. Methuselah being the biblical character in the Bible, the son of, I believe it was Enoch, um, oldest man ever lived, 900 and some years. Anyhow, that's not important. What is it's named after is because this star, in particular, you can look up and see it, is older than the universe. The star they figure is about 14.46 billion years old. And the universe is 13.7. So how you figure that is by the red effect. Do you ever go and see a plane fly toward you and the sound changes as it comes towards you and as it goes away? It's kind of like that with light. Light will go in a blue to red spectrum. If it's coming at you, it looks blue. If it's going away, it looks red. So that means the light that you see from this star right now is 14.46 billion years ago. So how can it be older than the universe? And I kind of have different ways of figuring it out. Okay, so if you take the universe, it starts as a singularity, and it expands in so many different directions. They figure the universe is a circled donut. Okay. So I'm saying if Methuselah's star is here, we are here, say, in the actual singularity of the Big Bang happened here. What you're looking at is distorted by the light going in this direction. Okay? So, as I fight for finding my cap here for this marker, there it is. What I was coming up with in the theoretical is something I'll make a little clearer to you. So if you ever have a black hole, which is a singularity, that's a bad example, but if you have an event horizon around it where light can't escape. So if I'm sitting here and I'm seeing my friend going this way, and they stop right there, I would never observe them going into the black hole, because the more gravity you have, the faster time goes. You'll experience this on Earth too if you don't think it exists. Like you see that you have to calibrate your GPS to the satellite, because the satellite actually loses a few seconds every year based on it being further away from the Earth. Time moves in relative dimension. So, same way with this. Now, if I'm here, I will go into a black hole. This might only take me like 5 minutes. But to someone out here, this may be 5 million years. That amount of time. So that means if I was on a spaceship, real long spaceship, I believe Doctor Who covered this idea, and I was here and I walked here, and I'm 5 years old, and I walk back here and then walk back. It may only take me a year to do this walk, but to someone here it might take 500 years. So I'd come back, 500 years would have passed, because as I went closer to this gravity, time moved faster. So what does that mean for Methuselah's star? Okay, and this right here. How can Methuselah's star be 14.46 billion and the universe being 13.7? Tells you something. It's closer to something that distorted gravitational time. So instead of going in a straight line, time went and warped to where, for what we see is 13 billion years, for that star to us it's actually 14.46, because space-time is more like a funnel in a grid in a matrix this way. As you go closer to gravity, you come back. It's time. Well, time is, yeah, relative, but that's why Einstein said general relativity, relativity to time, space, and gravity. So to solve that function, I was doing some calculation, posing some thoughts. I came up with this. I'm going to take the gravitational constant, universe gravitational time dilation factor as y. I'm going to go y equals SQ RT. I'm going to put 1 here minus 2 I'll pause this large calculation here. Okay, and then underneath it I'm going to put a 10. The value of 5 kilograms slash C oh, 1 3 8 E 6 M. Now, simplifying and solving that, y equals 1.45 E minus 8. Okay. So that's using what I just told you. And I'm going to throw in, it's using Methuselah's star, singularity of the Big Bang, time dilation, and cosmological principle with Friedman, Symmetry, Robertson, Walker metric to describe the universe's evolution. So what I want to really think about with the star itself, I'm going to go with time and experience by the star. So on that one, if you're looking for that one, it should be T. That gives you that differential. And that should come out to about 14.5 billion years. And thinking about that altogether, it's kind of strange to think that, something can be older than the universe, because we're sitting in one space and time, observing the universe from that space and time. So to us, yes, it's 13.7 billion years, but to other objects, moving at a relatively different space-time differential, based on the gravity and polarity and things that are also distorting it, they can actually be experiencing it at a different time than that. I hope that makes sense. I didn't want to post all these theories. I was just sitting there thinking last night about it and just found it really fascinating.